So we need to think about the geometry to figure out the polarity. And so this first case, basically we're symmetrical, right? The chlorine and the chlorine are 180 degrees apart. They cancel each other out. The fluorines, the three fluorines around the equator, right, they're 120 degrees apart and they cancel each other out, right? So that makes this molecule non-polar because of the symmetry. Molecule 2, we lose, right? We lose that symmetry, right? So if we want to think about the vectors and draw, fluorine is much more electronegative than chlorine. So it's a bigger vector. It's pulling the electron density, right, farther. So in that chlorine versus fluorine case, fluorine wins because we don't have symmetry. And we see the same thing here because that equatorial fluorine, right? It's not paired with another fluorine, it's paired with chlorine. It wins that battle. So that makes that molecule polar. We would see the same thing here because we don't have that symmetry. Again, these two equatorial fluorines are going to outcompete the chlorine, and that would make this molecule polar as well. And yeah, Rochelle, so for molecule 4, we'd see the same thing, right? Because we don't have that symmetry. This fluorine is 180 degrees apart from that chlorine. It's more electronegative. It's pulling electron density farther away. In all of these cases, right, fluorine is matched with chlorine, the fluorine wins. That would make molecule 4 polar. Molecule 5 is symmetrical, so that would be a tie, right? So that's non-polar. And then molecule 6, again, we lose that symmetry, right? We've got a fluorine matched with a chlorine. So molecule 6 would be polar as well because we've lost symmetry in that molecule, right?